So today we're going to be doing best time to buy and sell stock. So the question is, you're given an array prices where price of I is the price of a given stock on the ith day. You want to maximize the profit by choosing a single day to buy one stock and choosing a different day in the future to sell the stock. And we need to find the maximum profit for the strategy. So we can go through one example here. So with this example, we would want to find two indices that have the largest difference. So one way to do this is to find a minimum and then find the next largest maximum, which in this case is 6. So we have 6 minus 1, which is 5. But we have to be careful because we don't know what numbers follow. So for example, in this case, if we just had ones in the list, the maximum profit we would have is 0 because we would just not buy or sell anything. Or we would buy something and sell it the next day at the same price. So for the solution for this, we can go with sort of a greedy approach. Basically, we can keep track of the maximum profit and the current minimum. So the maximum profit, given we don't buy or sell anything, is 0. The current minimum, we can just choose the very first price to be the current minimum. So now if we have this, we can go through each price after the first index because we've already stored it as a current minimum. Compute if the profit is larger than the max profit, we can just rewrite or restore the new profit into max profit. And we can also update current minimum if we find a new lower price than whatever is stored in the current minimum. So that would be for price in prices, skipping the first index. If max profit, no, you just say max profit is equal to max of max profit and price minus current minimum. And then we can do current minimum is equal to minimum of current minimum and price. So we update both the max profit and the current minimum, and we should have the largest possible profit given that array. So we can just return max profit. Let's run the code. Okay. Let's submit it, see if it works. Okay. So in this case, we can analyze a time complexity is O of n, where n is the number of prices we have, or the number of days. Essentially the size of the list, because we have one for loop going through the entire list. The space complexity here is O of 1 because we're only keeping track of 2 variables which store just 2 numbers. So that should be it.